We're going to talk today about molds and mycotoxins and the indoor testing on this issue. This is what I do and who I am, etc. But more importantly, here we go with Brantley May and what all the things that he is and his certifications and licenses, etc. So you can see he's extremely knowledgeable. I can attest to that fact. Myself, having had the opportunity to see him a number of times and just talk to him as well. And this is why I asked him to join me, and he graciously accepted in coming and educating all our folks on the issue of indoor testing and remediation and all that. And there's a lot of it. So let me take you through some things. This is what, basically I see this all the time. I'm sure you see that, during rainy season, they go inside and then they leave things, till the next day. But by then you see mold growth. Here's another example of it's behind walls when the covering is removed. Here's wallpaper. Here's growing behind a refrigerator that was removed. And here's some things that are maybe not so obvious. Anyway, the top three questions I would say I get is, what's the difference between molds and mycotoxins? And what's the difference between the blood test and urine test? And can these mycotoxins come from food? Well, let's address one by one. And so there's 4 microbes that can cause infections. Okay, everybody's heard about viruses, especially with COVID, bacteria, parasites, and molds that can cause infections like pulmonary aspergillosis, which affects the lungs. Now, just to let you know, skin, such as athlete's foot, et cetera, those are also caused by molds, but those are not really very strong molds, and it's only on skin that cause problems. So all these 4 are living organisms. They have cell walls, and all 4 can be treated with prescription medications. These mold spores carry with them mycotoxins. It's like a key on a keychain. Okay, I have my car key on a keychain, and it's the mold spore and the mycotoxin. So these are toxins, though. They're not alive. They're like mercury or pesticides, arsenic. So they don't have cell walls. They're not microbes. They don't cause infections. They cause toxicity. Okay, and they're just a group of molecules. Mercury is very dangerous, as we all know, and it's very toxic to the body, but it's just a group of molecules, the same as any other kind of toxin, such as a mycotoxin. So mold spores carry mycotoxins with them. And a common expression that is that I've used for decades is, molds are like the gun, mycotoxins are like the bullet. So mycotoxins are toxic, and they're treated differently than molds, because molds are alive, toxins are molecules. And also, anything toxic takes a long time to treat. For example, in treating molds and mycotoxins, it takes me about 6 months or so to get a person well again. 6 months, folks, not years, including mast cell activation syndrome from molds and mycotoxins. Having said that, any kind of toxin takes a longer time to treat, because if you take, say, a bacterial or viral infection, you're over it in a few days. Not so toxins. Why are you over it for a few days? Because there's prescription medications that can be given for that. Okay. Now, what about foods? And what's the difference between urine and blood tests? Well, foods have tiny little amounts, some foods, usually in parts per billion. And this amount is way too small to cause any kind of a problem. And it's quickly and easily excreted in urine. Let me give you, for example, when you go to the supermarket and buy milk in the carton, 91% of that will contain anywhere from 1 to 4 mycotoxins, but it doesn't cause illness, does not make you sick. It does not live and grow into huge amounts in the intestine, and you have to pull them out with a binder. That's all hogwash. It is medically and scientifically incorrect. It is a minuscule amount. And let me tell you about how minuscule. I asked a mathematician once, what's a part per billion? He says, basically to that, it's take 100 football fields, cover them with golf balls. And once they're covered with golf balls, once you've had them all covered, you take from one golf ball away from these 100 of football fields covered with golf. One golf ball is a part per billion. So, and the amount of mycotoxins in food is highly regulated. There's 43 countries have signed the agreement on this. FDA, the European Food and Safety Authority, EFSA, the World Health Organization, United Nations, etc. Okay, so, and they say this is a safe amount. It's tiny, and they've proved it again and again over decades. It's not something relatively new. So let me go to the next point, and that is, what does the blood serum test tell you? They're telling you which 12 mycotoxins are currently in your body and how much is in your body. That's known in medicine as the body burden. Okay, this is a highly precise test. It's used by university medical centers for diagnosis, treatment, and research. The urine test is not used, period. The urine test reports on which mycotoxins you ate, and if it's positive, it's a good thing. Your body's supposed to be getting rid of this. Just like if you have for dinner tonight some asparagus, and afterwards your urine is going to smell of asparagus, that's the asparagus metabolite. That's what they're measuring. That's the one lab that does urine testing. It measures the metabolites. The other lab measures parts per billion. Well, that's exactly what you're getting rid of, and it's not affecting a person. That's not where the problem is. The problem is if it's in your blood, because blood circulates in all your organs. Okay, so the serum blood test is highly precise and tells you if you have toxins from a moldy environment, okay? Not from what you ate. Urine is what you ate, okay? Not from a moldy environment. And it can change day to day and week to week. So the most precise and accurate test for mycotoxins is both IgG and IgE antibodies to these mycotoxins, and you can get them at MyMycoLab.com. Okay, so you get 12 IgG, which is a toxic reaction, and 12 IgE, which is a mast cell activation, and how much is in your body currently. Now, according to Dr. Vujjani, the following points should be considered before deciding to use urine level of mycotoxin as an indication of exposure to mold from a water-damaged building. First, what's the source of mycotoxins in urine? It's from food. Why is the detection of mycotoxins in the urine not an indication of neoantigen, new antigen formation between mycotoxins and human tissue that play a role in the pathophysiology or the triggering of autoimmune and neuroimmune diseases? Well, the answer is this is because most of the mycotoxin detected in urine comes from food. And that's why the detection of mycotoxin in urine is not an indication of body burden of mycotoxins and should not be used as biomarkers for exposure to mycotoxin in water-damaged buildings. Okay, so can they come from food? Well, we just said, yeah, certain plants, etc. Peanuts, I love peanut butter. Beans, grains, beans includes coffee beans, by the way. This is in basically countries that are lacking any implementation of adequate food safety policies. So yes, there's certain parts of rural Africa and rural China where after harvesting of various wheats, et cetera, there's poor storage. So yes, that can occur in foods in Africa, certain parts of rural Africa and certain parts of rural China. Okay, so the amount of mycotoxins in food has been shown in a number of studies to be below what is called the tolerable daily intake, TDI, that's set by the FDA, the EFSA, UN Food and Agricultural Organization, World Health Organization, et cetera, all these, and 43 countries, remember, have signed the agreement that this is how they will keep their food. All right, now here's a study from Dr. Frey and his group, published 2 years ago, showed that the 1 to 4 mycotoxins are in milk. Like I told you before, 30% of milk has 2 to 4 mycotoxins, but all of them were well below the tolerable daily intake and easily excreted in urine, which is what you're testing for when you test urine. It doesn't mean it's made you sick. So, what is the best treatment for mycotoxins? First, before you do anything, and the first rule of toxicology is get the patient away from the toxin or the toxin away from the patient. This is the most difficult part. And a person's health cannot be restored if they continue to be exposed to molds and mycotoxins. No treatment will work under those conditions. So what you have to do is clean up the air, get rid of the mold and mycotoxins. So here's this study from earlier this year that fungi, molds, it's like fungi and molds is like saying car and automobile. Fungi are well known as common contaminants of the indoor environment with the ability to grow on many types of building materials and to subsequently release biological particles into the indoor air. These are the mycotoxins with the mold spores. The most frequent fungal species on surfaces are also those most commonly identified in indoor air, regardless of the geographic location, both in Europe and in the United States. This was published in February of this year. So now I'm going to give you Brantley May, and he's going to take it from here.
Thanks, Dr. Campbell. Yeah, I let Dr. Campbell handle all the clinical fancy doctor stuff. I'm just the guy that runs around in houses and looks for mold. So the biggest question that I get on my end of things, right, and talking about the environment, is how do I find the right inspector? Because when you're trying to deal with a health concern and you get someone out there that charges you $2,000 and you end up not getting any answers, it gets quite frustrating. Not only frustrating, but it actually gets a little bit of hopeless, because you kind of feel like you're not getting anywhere and you're spending money and you're turning wheels. That's a big part of what I see in this field, and it's really upsetting. So these are just going to be a couple tips that I can give you to help find the right person. So the first question that you want to ask when you're looking for someone is, does the mold inspector prioritize the investigation? Are they just talking about sampling the house and giving you all these fancy tests and telling you that you're going to get they're charging you per test? Or are they going to say, no, you're not paying for tests. You're actually paying for my time. You're paying for my expertise. You're paying for my know-how. You're paying for someone that can walk in the house and understand how a mechanical system works. How does the air conditioner work? How does ventilation work? How can we assess a problem with the design of the air conditioner? How do we create a good dehumidification plan for you if that's something that you need? What about the building? How is the building operating? Is the flashing properly? Is the roof correct? What about the crawl space? What about the attic? Do they tie into the house at all? What about pressure problems? These are all like engineering and scientific concepts that your mold inspector should be able to understand if they're going to perform a good investigation. Otherwise, what we see a lot is that these inspectors, which I don't even really like to call them inspectors, they're more like mold testers, is they say, okay, we're going to do this many samples, we're going to be this type of samples, this is how much it is per sample, and sample. You're paying for samples. The most important thing to understand about sampling is that all testing methods are limited. Every single type of environmental sample has some sort of limitation. It has pros, but it also has cons. It's a specific tool in the toolbox. There's not one tool that fits all. And so just keep in mind that any sort of testing can either give you partial information, or it might even mislead you because you don't have the other information. You don't have the other pieces of the puzzle to see the whole picture. That's what the visual inspection is for. So that leads us to our second bullet point. Do they use the scientific method? So we learned about scientific method way back in like the high school days, but basically what the scientific method is you use data, visual observations, and your assessment on what's going on to then develop a hypothesis. Once you've developed that hypothesis, then you test. After you've already assessed, after you've already developed a hypothesis, you test it. And the only reason you test is to verify if what you were thinking is either true or untrue. So I'll give you an example. If you go to a good doctor, which unfortunately there aren't many good doctors these days, but if you go to a good doctor and you walk right into the building, what's the first thing that the doctor's going to do? He's not going to tell you to shut up, don't say anything. Let me just stick you with a pin and get your blood real quick and send it to a lab. No, that doesn't make any sense. They're going to tell you, well, the first thing they're really going to ask is, what brings you in today, right? What brings you in today? How long have you been feeling like this? What else has occurred when this started to happen? Okay, well, where is this happening? So all of these questions is exactly what a good mold inspector will do. That's how you start the scientific method. I come in, well, what's going on? How long have you been feeling like this? Where are you reacting in the home? What changed 4 months ago when you started getting these symptoms? What is the history of water damage in the building? Point me to every single thing that's happened since you've lived here. Do you know of anything that's happened before you've lived here? And so getting all these questions and asking the right questions, a lot of times the right questions mean we don't even have to test. We haven't even gotten to testing and I can solve the problem just by asking the right questions. So what does the doctor do next? The doctor's going to maybe check your ears, check your eyes, check your nose and throat, maybe smack you on the knee, check your reflexes, check your respiratory rate. What are they doing? They're doing a visual assessment on you. They're trying to understand what could be going on with you. They haven't tested anything yet, right? That's the same thing we're going to do. We're going to look around the house. We're going to look for reasons why you'd have mold in the first place. If we can find the reason why you have mold, we don't need to test. We can find the mold. We know how extensive it is. We know how to solve it because we know what caused it, right? So being able to find the visual observations is so crucial. So let's go back to the doctor then. All right. So now what does the doctor do? Maybe they take your blood sugar, maybe your blood pressure. Maybe they try to get your heart rate and all of these things to do an assessment with preliminary testing is what we would call it. And a good mold inspector is no different. They're going to go in, they're going to check with moisture meters, thermal imaging, maybe some particle counts, and doing things on site to develop a hypothesis. So finally, after we've done a really thorough investigation, we've asked the right questions, your doctor will say, I think this is going on. Therefore, we're going to do this type of test. And the only reason we're doing that test is to either prove or disprove that this hypothesis I created is correct or not. It's no different in the environment. I'm going to go into the environment and I'm going to say, okay, I think that you could be having issues here, here, here. Based on the type of issues you're having, this is the right type of test. And the only reason we're doing the test is to see if I'm correct. And if I'm not correct, if the tests show something different than what I've developed as far as my hypothesis, we go back to the drawing board and we start over. If you go straight to just doing testing and they're only doing testing, what that means is they're skipping all of the important stuff and they're guessing, right? And you don't want to spend $1,000 or $2,000 or $3,000 on all this testing for guesswork. We call that the shotgun method. You just test, 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 and hopefully you find something, and hopefully it's not misleading information. So having someone that uses the scientific method, who understands building science, that is how a building operates, the building envelope. Building envelope is what keeps the outside out and the inside in, right? So that has to be done well. The mechanical systems, behaviors in the house, that's the knowledge of building science. Someone that also understands mycology. Mycology is the study of fungus. So how does the mold grow? Where does it grow? What type of ecology? Ecology meaning, what does it like to grow on? What does it like to eat? What temperature does it like to grow? If you understand those things, you could track mold down fairly easily, actually. And I might even be able to look at a clinical lab report from you and say, oh, you're dealing with this type of mold? Oh, well, they only grow in this type of environment. And it's a lot easier to pinpoint issues. So the massive amount of knowledge you gain from understanding mycology to implement that into the building is huge. And then very important, do they provide a protocol, meaning recommendations? So they do their assessment and they understand what's going on in the building, then they can write recommendations. The recommendations are basically there for the remediator, saying step 1, do this, step 2, do this, step 3, do this. If they can give you that, that probably means that they were actually paying attention on site. They actually looked around enough to be able to write a plan of action. Also, a lot of these guys will actually, they won't tell you that a protocol is included because it probably isn't. And then they say, oh, well, if you want a protocol, it's an extra $400. So always ask if a protocol is included. And if you're trying to find a good person to find, I mean, there's always the bad lemons, right, in the lemon basket, but I put down here the ACAC. I'm not affiliated with them at all, but I am one of their certificates. That's probably one of the best places to look for an environmental person. They have a little option in there where you can type in your state and you can look for people that are certified near you. It's very hard to get some of the higher ACAC certifications. So if you get someone through there, they've already done a lot of the vetting for you. So that would be what I recommend for them. And before we get to the next slide, let me look at some of these. Brantley, is there a hierarchy for mold toxicity, or should all molds be avoided? Well, all molds. So, okay, here's the thing. The word all is interesting because mold is around us all the time. I'm breathing it right now and it's normal. So you can't avoid all molds. The point is to make sure that there's nothing abnormal happening in the house that would cause an abnormal amount of mold. Mold shouldn't be growing in the home. It doesn't matter what type it is. There are some molds that are not toxigenic. However, they could still be allergenic. They could still be pathogenic, meaning they can cause disease. So no, not all molds are toxigenic, but all situations that cause an abnormal amount of mold growth should be avoided. And oh, that's a good question. What steps am I taking on a daily basis to make sure that I don't have ill effects? I do have ill effects from my career. All right. I have an autoimmune disorder and it's very hard to manage in this type of industry. So those of you that are dealing with this stuff, I get it. I have my highs and my lows, but the best thing that I do is I spent about $3,000 on my respirator system. And it took me years to do that and get smart enough to do that. But I bought really good equipment. I know when I get into a building, if it's a hazard, that I suit up a little heavier, and then I make sure that I rest and take my days off. And I'm really radical with my diet, making sure that I'm staying healthy and exercising. That's what I do. Okay, go ahead.
So there's over 500,000, 400,000 to 500,000 molds, types of molds, but there's only about 24 that cause problems in humans. Now, there's some molds that cause problem in certain types of plants, shrubs, certain animals, etc. But for humans, you're going to be breathing mold spores, etc. But it's not going to hurt you, except for those couple dozen that can and will cause infection or toxicity.
Yep, and it also has to do with concentration. There's going to be cladosporium flying around outside. There's going to be some aspergillus flying around outside on days, especially rainier days. But it's all about, is it an abnormal amount, and am I enclosed in the house with them? You know, that's a problem. So what type of mold test is best? Just to repeat myself, all testing methods have limitations. Testing's not designed to find the source of a problem. All right, let's get that very clear. If I take an air sample in this room and it shows wildly elevated levels, where is it in my office? It gives me zero information on that. If I take an ERMI in this room and it says my dust, or worse, I take an ERMI in throughout the whole house and I compile all that dust together in the whole house and it says elevated, where the heck is it? I just spent that money on nothing. I would have rather spent it on someone that can actually investigate the house thoroughly. So testing is only there for documentation to understand, what's going on is about the inspection, but to document it, that's what the testing's for. If you're in litigation, insurance, those types of things, to prove or disprove a hypothesis, or to determine what type of mold you're dealing with. Sometimes you're having clinical issues and you want to compare the mold that you see in the house with what you're dealing with and see if there's any correlation. So
Next slide.
I'm going to go through some pros and cons of some samples that you probably see often. And that way you're a little more educated when you're dealing with your mold inspector on what's good or not. So swabs and tape lifts are what we call the gold standard because they're very, very simple. These are used by microscopy. So see if I can bring my camera down here. So this is my travel microscope. And with just something like a tape lift, I can put it under a microscope and immediately tell you what's going on. I can look at it physically with my own eyeballs. I don't have to send it to a lab to get PCR tested or dust tested or analyzed chemically. With these types of methods, they go to a microscopy lab for microscopes and they can see it. Let me see if I have a tape lift on me. Here we go. It's actually probably the most simple thing in the world. So it's just a microscope slide. It comes with a microscope slide and it comes with literally a piece of tape. Okay, it's not very complicated. But what we do is we take off this piece of tape. And what I like about tape lifts is you could pull directly from the surface. So I'm able to actually get this off. I'm able to actually pull the mold exactly as it is. So for example, if I'm worried about mold landing on my mouse here, right, spore settling, well, what do? I take this piece of tape, I stick it on, and then I pull it off. And all I got to do is stick it on a slide. And we can actually look at that under the microscope and count the spores that we see and even tell you what type of spores we see. I can identify Cotomium, Stachybotrys, Penicillium, Aspergillus, Trichoderma. It doesn't matter. You could see it with something just as simple as a tape lift and count them and quantify how contaminated is this mouse, right? And you can imagine if a piece of tape and a skinny piece of glass, it's actually quite affordable to do this. It's a cheap type of test compared to other ones. And so it's great for checking contaminated contents, but it's also good for checking mold that you visibly see. Maybe there's mold growing on a wall and you want to see what type it is. Hey, tape lift is great for that too. Swab is a very similar process. The only difference is you swab it and then you put it under a microscope. But the pros, very easy, effective, low cost, very quick turnaround time because the labs can look at this in 5 or 10 minutes. You can't really contaminate it very easily, but there are some cons. You're not going to get species. So the lab will tell you that it's Stachybotrys, but they may not tell you it's Stachybotrys catarum, right? It's a very small sample size, right? If I wanted to know if this whole room was contaminated, look how small this little square is, all right? I'm not going to be able to know if the whole room's contaminated. I just have to take a sample area to infer if the area is contaminated. If I were to check this whole room, I'd have to do 1,000 of these. And it's very dependent on a good inspector. Sometimes this gets a bad rap, but it's because the inspectors don't know where to sample or they're using it wrong, or they get a very heavy load where the lab can't read it. Like this right here, it doesn't look like anything, it's see-through, but that's plenty. I could see skin cells, fiberglass, dust, starch grains. I can see all sorts of stuff under this thing. Some inspectors that don't understand the microscope work, what they're going to do is they're going to take clumps of dust, look at it under a microscope, and the lab can't see anything. So it's very dependent on the person doing it. The next sample that we have Oh, Dr. Gale asked, where can a homeowner buy a tape lift test, and where can they be sent for analysis? So there's a lab. I'll put it in the chat, called Eurofins AEML. Eurofins AEML. That's a lab down in Florida, and they have these kits just like this, where they give you a slide and a piece of tape, and you can send it off to them. It's very easy. It's very affordable. It's a great test. Eurofins isn't the only one. There's multiple labs. There's also Priority Lab is another great lab that does this. So that's what those would be the two that I would personally recommend, but there's many labs that do tape lifts. Any lab that has a microscope and looks at mushrooms and fungus. So, all right, passive petri dish. You guys have probably seen these. These are mold test kits that you see at the Home Depot or the Lowe's. And unfortunately, you can tell I like these, huh? Look at the pros. A big old fat nun. So here's the problem with these, all right? They're very misleading. They don't give us a lot of information, and I'll tell you why. The way that these are designed is it's a petri dish that has a nutrient that's optimized for mold. It's supposed to grow mold. You want to grow mold on it, right? So it's got the perfect amount of moisture. It's got the perfect nutrient. You stick it on a table, and what do you think is going to happen? Of course, it's going to grow mold. There's mold everywhere. It's flying all over the place, right? And so it doesn't give you a good indication of what you're being exposed to or how you're being exposed, what type of mold you're being exposed to. And the reason I say that is because this is one type of nutrient, right? Mold likes to eat on numerous different things, lots of different things. And so if I only put one nutrient out, what are the chances that every single mold is going to grow on that? Not likely. So not only is it going to just grow mold anyway and scare people, but secondly, it's going to give you only partial information. Because when I send it to a lab, the lab's going to only count what they see, and they're going to say, oh, no, yep, everything looks good here, if there's nothing dangerous on there. But your house could be loaded with some sort of toxic mold that just doesn't grow on that nutrient. So it's very inefficient in that way. Thirdly, most molds, the vast majority of molds flying around through a house are what we call non-viable. That means they can't grow. That it'll land on a dish, even under the perfect conditions, it just won't grow. And so you're not catching the vast majority of non-viable spores in something like this, yet you're still inhaling them. So this is not a good indication for exposure. You don't know how much you're getting exposed to. And most of these tests, they don't even check for species anyway. So it's very unfortunate, and they may take a couple of weeks to grow. So it's a very slow turnaround time. There's really not much benefit that I can think of to this, unless you want to buy one for your kids for a science experiment or something. Evan asked, Brantley, if someone is interested in this as a career path, where should they start? Well, it depends on your state. The first thing you want to do is some states have certification bodies that are required. Florida, for example, is requires to be licensed. So you have to have 4 years of experience before you can even get your license. So if that were the case, if you're in a state like that, trying to find someone that can hire you that's already licensed so you can gather your experience. There's also great training. If you're in Florida, the best mold inspection training that you can get is from a company called AMA, American Mold and Moisture Association. I think their website's amaeducation.edu or .com, something like that. I teach with them often, and they're great. So if you're trying to get certified, Florida's a lot more regulated than some other places. I know you guys up in the northwest, it's like the Wild West out there. Okay, so the ERMI test. This is one that has been getting a lot of traction within the last 5 years. And it's very unfortunate because it's already very well known and well established amongst professional environmental scientists that this test there's no validity to it. It's very inaccurate. It's very misleading. But let me explain how it works. This test uses what's called PCR, polymerase chain reaction testing. They're checking for DNA. You send a clump of dust, right? You collect some dust throughout your house. You send it to a lab. And what they're going to do is they're going to dissolve in that dust a solution to figure out how many trillions of strands of DNA are in this dust. and they send it through a fancy process that can actually say, okay, well, we know what the DNA fingerprint, if you will, of Chitomium is. So let's look for that fingerprint in this dust. And if we find it, we can just try to count how much we see. So PCR testing is a great method for other things. But the problem with the ERMI was designed by the EPA, the Environmental Protection Agency, as research. It was a research tool for actually people with sick building syndrome and asthma. It had nothing to do with mycotoxins at all. It was literally just people getting sick with asthmatic symptoms. And so it was designed, although never really complete. The research wasn't really, the testing methods were never validated or certified or peer reviewed or anything like that. And it kind of just fizzled. Well, somehow these labs got a hold of these things and said, hey, this is a great idea. Let's start using this. But the problem is it kind of got away from the EPA, as many things do, right? And now they're trying to tell people, hey, stop using this. This isn't a good test. It's not validated. It's misleading. The scoring metrics is on very limited information. We need to figure out how to stop doing this. And they've actually been trying to enforce that. But here's the problem with the ERMI. I want to lay it out for you real quick. Let's go back to that slide. So here's the issue. Look at this score up here. All right. So if you're above 0, you're still kind of in the yellow. Once you hit 5, you see where the 5 is on that graph. Now you're in the red. If you're below -4, you're good. Where does that come from? What the ERMI does is it takes, they have what are called normal molds or good molds, and then bad molds, and they compare them between each other. So they minus the good ones from the bad ones. So if you have 10 bad molds, but you have if you have 10 good molds, so you got 10 good molds, 5 bad molds, your score is -5. You're good. Well, wait a second. What about the 5 bad molds? No, it doesn't matter. You have more good molds. Okay, that's weird. So let's do remediation. Remediator comes in. Now you have 0 good molds and only 1 bad mold left. You got rid of like 14 molds. So you're doing great. No, I'm sorry. Your score went up. Now it's 1. You went from -5 to 1. The house got worse. This is the logarithm that they use. It doesn't make any sense. And those numbers on the side where it says this is 10x more than a house is, or 100x more than your house should be, those are based on very limited studies. And big numbers scare people. And unfortunately, nobody knows what those numbers mean. They just look at big number and they get scared. And so it's just very misleading. It scares a lot of people. Most of the tests flag, even on places that I know are clean. And it's also expensive and it takes some time to get back. So, all right, spore trap sampling. This is probably the most common thing that you're going to see in a house be done. It looks like this. This is a spore trap sampler. And this is just a pump. All this does is just suck air. That's it. It's just sucking air. But where the magic happens is in the cassette. So at the top of the cassette, you have a hole. And at the bottom of the cassette, you have a hole. And you stick that on there and air gets sucked through the cassette. There's a microscope slide right in the center of this. But what's special about this microscope slide is it's sticky. And so anything that comes through here, it gets impacted onto the sticky microscope slide, and which is not just mold, by the way, all sorts of particulates in the air. It doesn't just take mold. But of course, the lab's only looking for mold. So it takes all of that stuff. They look at it under a microscope and they're able to physically, with their own eyeballs, count how many mold spores they see, what type of mold they see. And that can determine, this is probably the best way to indicate your inhalation exposure. Because if I take dust from a corner of the room, it doesn't tell me what you're exposed to, right? But if I were to go to your house and you say, Brantley, I sit in this desk 8 hours a day, guess where I'm going to put this? I'm going to put it right here where your mouth is, and I'm going to run it. And it's going to run 15 liters per minute, which is very similar to what we inhale. And it's going to give me the best indication of what you're breathing. And then I send it to a lab, and very accurately, we can physically look at it and tell you what's going on. It's very different than a chemical test where they have to use analyses to guess. So this is actually a physical human counting it with their own eyes. It's very low cost. It's probably one of the more reliable tests. Quick turnaround time because it's just under a microscope. But the cons, it's only a snapshot in time. So you run the test for 5 or 10 minutes. You might be in there for 8 hours. That's not a great determination of what's going on. A lot of times it could be performed incorrectly. And this is where it gets a bad rap. Some home inspector that decided to get certified, he decides to start doing this. And unfortunately, he doesn't understand the equipment. He doesn't understand the science, and you get negative results. And unfortunately, it's more common than you think. So if you were to take one of these, what do? Well, when you're taking it, you want to aggravate the area. It's called aggravated sampling. Most inspectors don't do that. So what do I mean by that? Well, if I'm putting this in a room, let's say your kid's room, are your kids just standing in the middle of the room like this? No, we wish they were, right? No, they're running around all over the place doing crazy stuff. So you put this in the room, and then what am I going to do? I'm going to kind of move the comforter a little bit. I'm going to open and close drawers, cabinets, open and close doors, move my chair around, just do things that you would normally do in the environment. Nothing crazy, right? You don't have to go like taking a sledgehammer to the walls, but something to stir up the particulates that might be resting. That's when you get exposed. You don't get exposed by sitting in the middle of your room. If there's mold growing in your house and it's settling on your clothes or something, you get exposed when you're going looking for your clothes in the morning, or when you open up a drawer, when you're causing this airflow movement. So that's what we do. A lot of inspectors don't do that. The accuracy is also dependent on the lab. You want to have a good lab that can actually analyze the whole sample. You know, there's a lot of labs, when they get this slide, they only look at 25% of it. They go 25% and they say, okay, that's pretty representative of the sample. Let's multiply by 4. So they guess. A lot of labs don't even go to the highest magnification they should, and they miss molds. So having a really good lab is really important too. And a good inspector will use a good lab. Home inspector or whatever, they probably just got sold on something, and they just use whatever lab they got an email for a sale on. And so knowing your lab is very important. So this is very important. This is where it comes down to understanding ecology. Ecology is the relationship of organisms to each other and their surroundings. So where is the mold growing? What does it like to eat? What temperature does it like? What moisture level does it like? If you understand these things, then you can track things down in a house fairly easily. Each species of organism has their own environmental niche. And the more you know these things, the easier your job gets. Matter of fact, for me, it's kind of like second nature now when I'm looking for these molds in houses. And you could do it too. You're good with ecology, just in other areas. Let me ask you this. Think about a polar bear. Where's a polar bear? What does it like to eat? Where does it like to live? What temperature does it like? Okay. So if you saw a polar bear walking around in Florida, kind of weird, right? What about a black bear? So this is exactly how we do this. If I see something like chitomium in my air sample, or in a direct sample, or in a clinical lab result, I know where to look, because I know chitomium is very hydrophilic. Hydro being water, philic meaning loving, loves water. It needs a high level of moisture in order to thrive. So I know, oh, if you got chitomium, you're probably dealing with something like a flood or a leak or some plumbing issue, something big, right? However, if you have aspergillus, maybe aspergillus can be quite xerophilic, dry loving. And I know that sounds weird. You're like, what? Mold dry loving? That doesn't like dry environments. Well, it needs moisture, of course, but relatively to the other things, it likes quite drier environments. So understanding that, well, aspergillus, if it doesn't need as much moisture and it's xerophilic, it prefers drier environments. Well, now we know it can grow with something just like high humidity, or maybe condensation, or just a little air infiltration as the hot and humid air comes into the house, smacks into a cold surface. So we should look for areas like that. They're not going to grow in floods and leaks unless at some point it was drier in that area. So understanding the mycology is huge. That's what we would do if you showed a good investigator your clinical lab results. We would tie that in with the ecology. So we'll talk about some common molds. Cladosporium, one of the most common molds in the world. Now, you're going to see it everywhere. It's ubiquitous. Ubiquitous meaning everywhere. It's in Alaska, it's in Australia, it's in Florida, it's everywhere you look. And many of these species are known to be cryophilic, meaning cold loving, right? They are very versatile. They can grow in a wide range of environments. You'll see it in an attic and you'll see it in an HVAC system. There's not many molds that can grow in HVAC systems. So if I'm looking at your lab results and you're telling me that you're dealing with lots of cladosporium, the first place I would look is your air conditioner, because I know it likes cold environments. And so it's a great key. Stachybotrys, Chaetomium, Fusarium, these are all what we call hydrophilic molds. So if you see anything like this on your lab results, you know you're definitely dealing with some sort of water damage issue somewhere, something that requires a lot of moisture. I mean, these require like dang near sitting water at some point for it to grow. And the toxins are pretty hardcore. Trichothecenes, ketoglobicins, and then deoxynivalenol, which some people call vomitoxin. And so the toxins in this area are quite heavy. And so when you see things like this on an air sample or a swab sample, you want to treat it seriously. And sometimes it's kind of tricky to find these in air samples because they're not easily disseminated when wet. So if they're growing in an area that's still wet, it's a wet environment, you won't really see them flying around in the air. Stachybotrys, in fact, can be quite sticky, so you don't really see it leaving its space unless you start disturbing it or drying it. Brantley, how often are you spending time trying to explain to an unaffected partner or spouse that, yes, this can affect their significant other initially and not themselves immediately? Why does that always seem to be a driving wedge when it comes to couples or families? So I'm not in the category of persuading people. I don't really do that. My job is to bring objective information into the conversation and bring in facts. And when I do deal with this a lot, whether it's the wife dealing with symptoms and the husband isn't, or the husband dealing with symptoms and the wife isn't. My wife and I are like that. I'm extremely sensitive. My wife is like, she wouldn't even know that her hair was on fire, So the thing is, the best thing you do is just bring in facts. Now, why does it always seem to be like this and driving wedge? Well, I would say that people are different. This is why it's so hard. This is why there's no regulated action levels for mold, because people are so wildly different when it comes to these things. I mean, it's like, just imagine the two people of vastly different bodies and metabolic systems drinking alcohol, right? One is going to have, it's going to get drunk a lot more than the other one. And it has nothing to do with how much they're drinking. It has everything to do with their metabolic system. And that's the difference. So, but yeah, it is unfortunate. I see that a lot going through this, but usually when we start finding issues and correcting them and your symptoms alleviate, the husband or the wife or whoever it was, they start to see, when they start seeing your energy increase, they start realizing, oh, okay, this was a real thing. But unfortunately, there's so many bad inspectors out there, they miss things. Okay, common molds, Aspergillus, Penicillium. Many of these species are what we call thermophilic, or warm-loving, and xerophilic, dry-loving. So think about a hot, humid climate. You're going to see them all over the place. Some species of these can create aflatoxins and multiple other toxins. And they're very tiny spores, very tiny stuff. We're talking about like 2-3 microns. A width of a hair, you're talking probably close to 200 microns on a width of a hair. And so these are incredibly tiny things. And they fly around very easily. They grow asexually, meaning they don't need a partner. They could just reproduce very quickly. So very scary molds. Everyone's worried about the Stachybotrys and the Chaetomium. And don't get me wrong, those are bad, but these are the ones that actually freak me out because they grow so rapidly. They grow in such, drier environments, like just high humidity, condensation. And also, Aspergillus and Penicillium, they have multiple species that are known to cause disease too. So it's a nasty one. So if you want to know more about, kind of what I do, you could check out our TikTok, Building Science. I'm also on Instagram. Just look up my name, Brantley May. And if you have any questions, just hit me up in one of those DMs. More than happy to help you guys out.
So, by the way, just to give information, you have to understand that there's mold spores everywhere, but they're not going to affect you unless they're pathogenic in medicine. So some mold spores, I mean, nowhere is there no mold. Okay, it's just part of, as Brantley just showed us, it's part of the ecology, it's part of the world. It's found in jungles. By the way, there's mold in the space station, according to one study. So having said that, it's, and I get this all the time, what, is it from this or from that? Well, you just heard from the expert that I trust about all the different kinds of tests, the pros and the cons for each test, and an explanation of why. So I encourage you to review what we have, just what Brantley especially has talked about today, as soon as this webinar is made available by recording. And I just want to share one more thing with you, and then I'll go back to the previous slide. Okay, this is mold and mycotoxin in naturally infested indoor building materials. So here is fungi saying containing foodstuff are still a global burden, affecting developing countries much more than developed regions such as the European Union, where strict regulations are ensuring food safety. And in order to provide a secure identification characterization of indoor mold exposure, directly contaminated building materials, here's exactly what we just went through, what Brantley May explained to us, etc. So I'm just confirming for you that everything that was said here today in this webinar has been shown to be from published studies. It's just not opinions, which are all over the internet. If you go to the internet, you'll find ERMI is the best one, and it's not. It's one of the least best, if you want to even think about it. It's not a good test at all. So anyway, here's some questions we're getting.
All right, let me take a look. Yeah, I'll also add too, any questions you guys have about resources, standards and guidelines, anything we went over today, throw it in the chat or even in the YouTube if you guys are watching the YouTube, and I'll keep up to date with that. That way I can make sure that you get real resources, because I'm not a big fan of Dr. Google, and it's going to lead you astray. And so we use scientific evidence here. And I would also say, if you're trying to get into this and you're trying to get excellent resources and guides that have been vetted by professionals, and you're using Facebook, there's a Facebook group. I'm not an admin or anything. I'm just a partner there, and I'm there to answer questions too. I'm just a visitor, if you will. But the mold and mycotoxins, healing your home and body. So if you do want to join a Facebook group, those guys are awesome, and they have guides on cleaning, inspection, how to find the right inspector, links and articles and all that stuff, which might answer a lot of your environmental questions. So so you have me as a resource if you need anything, but that right there, they did a lot of work in creating guides on how to help people. So okay, question from Jay. What about mycotoxins from contaminated items? How do they multiply in non-mold environments? So that's a great question. They don't. Mycotoxins aren't going to multiply in non-mold environments. Mycotoxins don't exist in non-mold environments. This is a very big, this is a lot of misinformation that's being spread around by non-mycologists in our field. And that is that you have your molds, and then mycotoxins are some gas that goes independently from the mold. That is absolutely not true. They don't go separately. The mycotoxins are bound to the mold. They're bound to the spore. They're bound to the hyphae, which is basically the roots of the mold. They're bound to the fruiting body. They're bound to the structures. They don't fly off independently on their own. And so this is why testing, like checking for mycotoxins directly, is sometimes unnecessary, because we can test for mold spores and hyphal fragments. And if we see that there's no mold spores or no fragments of mold or anything like that in the air, which with a microscope can identify, then as a surrogate, we know that there's no mycotoxins, because they don't fly around on their own. So, and they're certainly not going to multiply. Just like Dr. Campbell was saying, they're not growing and they're not living. It's a toxin. It's just like mercury doesn't just multiply or lead doesn't multiply. Dr. Campbell, anything you want to say?
Very good answer. Thank you so much for saying that, because
Okay.
people get confused and they say, okay, well, there's a lot of misinformation in Dr. Google. So this is why Brantley May and I rely on what is real knowledge, facts, publications in medical journals, etc., not on opinions, because the opinions are all over the Dr. Google part. And there's so many so-called experts out there, but what makes them an expert? I've published over 100 articles. I have chapters in medical textbooks, and I've lectured at 4 or 5 different medical schools. So have they done any of that? They might have a book, but that doesn't mean anything. Anyone can write a book and publish it today. So go by what you just saw. We just showed you the body and the building. We took it and showed, and remember what I said, you cannot get well unless you find the mold and get rid of it. If you don't do that, there is no medication that can help you. And so you've had both answers here for you today. And you can also watch my webinars if you go to the YouTube channel for MyMycoLab. My 40 webinars are there. They cover everything from hormones to the brain, et cetera, et cetera. So I wish you all the best of luck. I think we're going to stop it at this point. We're at the bewitching hour. And so I want to really thank Brantley May for sharing his wonderful knowledge, facts that he gave us, the pros and the cons. Please watch this again. It'll be posted on the MyMycoLab YouTube channel. All righty, everybody.
Any questions, by the way, that we missed in the chat, go to the YouTube and put them in there, and I'll answer them on the environmental side. So that way we have a chance to answer all the questions for you guys. You can go there.
All right. Great. Thank you all very much. See you next week.